Alright, so we're looking at rational exponents. Rational exponents. When I say rational exponents, that means the exponent is a fraction. The exponent is a fraction. This exponent being a fraction comes from a root, right? Like a square root or a cube root. That's where it's coming from. Alright, so let's zoom in on the first problem. Dun, dun, dun. And of course we can't see it now. Okay, so what we're going to do is rewrite this fourth root as a rational exponent. You're going to put the regular exponent in the numerator and the root in the denominator. And that's it. So when I ask you to write using rational exponents, that's all I am asking for. I am not asking you to do any calculations.
So is this all going to be it?
That's the answer?
No, there's three parts to this, no. And that's the answer, yes.
What?
Alright, example B.
That's the answer.
So here, the weird part is, usually in math, if you don't see a number, you assume it's either a 1 or it's a 0. This is the one place you assume the number is a 2. That's what square root is, right? So what you're going to do is write that as 6 to the 1/2. And that's the answer to B. So all we're doing is rewriting. Yes, sir?
You said assume it's either a 1 or a 0. How do you know which one it is?
Well, it depends on the context. Right? Like example, if I tell you x is my variable, what's the coefficient of that? What's the number in front of x? 1. So you assume it's a 1. And you knew it was a 1 because of the context. Right? What's the exponent?
0.
1. This one has an exponent of 1. The context. Okay? This time, if it's a square root, that's the only time you're going to assume it's a 2. When there's no number there. Alright, look at C. Here, you don't have to assume anything. It's a 3. However, what's the exponent on x? 1. So it's x to the 1/3. Right? Because the exponent is 1 and the root is 3. That's the answer to C. X to the 1/3. Right, Lincoln?
Right.
Now I'm going on to example D. Example D. So I have an exponent of 2 and I have a root of 3. So you're just going to write x plus 2 to the 2/3, right? The exponent goes in the numerator, the root goes in the denominator. Example E. Alright, so here, remember you're assuming the exponent is what? 1. So it's going to be 3x minus 1 to the 1/5 power. Very good. Okay, F is a mess. Okay, F is a mess. Oh well. Alright.
It would be 3x. The second 3 is 3 over 2.
Yeah, well, the 3 is the problem, right? So you want to write it like this first, 3x3 to the 1/2. Okay?
What?
So remember the exponent is 1/2, right? If it's a square root, remember that's a 2.
Yeah.
Now, the reason why I had to write it this way is because of that 3. Okay, you can't just write 3/2 because of that 3. What I'm going to do is distribute that exponent. Okay, by the way though, if you stopped here, I'm okay with that. But for those of you who are just wondering what's next would be 3 to the 1/2, and then it's 3/2. Okay? So that's when it's 3/2, when you distribute that 1/2. Okay? But as far as I'm concerned, if you stopped here, that's perfectly okay. If you stop here, that's perfectly okay. Now, it might not be okay later when we're trying to calculate something. Okay? But, so if you want to calculate something, you're working with this version. Okay? But this is perfectly okay when it just says rewrite it. Rewrite using rational exponents. Alright. Now we're going to do it the other direction. In the second part, we're doing it in the other direction. So what's the root in this problem?
1.
The root is 7. Right? So it's going to be 7th root of x squared. Right? The exponent is 2. The exponent is the numerator. Alright? What's the root in example B?
4.
4. So you're going to write 4th root of x. Do I need to write an exponent?
No.
No. Very good. And what's c then?
2 root 3.
All right. But remember, when it's a 2, you don't need to write a 2. This is that one weird space where you don't have to write a 2. Yeah, so it's square root of 3, yeah. Okay, moving on. Example D.
What about C? Did y'all just do C?
Yeah, it's root
Yeah.
3.
You blinked and we did it already.
This was x minus 4 with
To the-
with the 3 on the outside.
3 on the outside. Okay, by the way, if you wrote it like this, if you wrote square root of x minus 4, and then you put it in parentheses and you rose it to the 3rd power, that is perfectly okay.
With the 3.
This is the better one, but this is okay. This is not wrong. Okay, that's not wrong.
Is the 3 on underneath the line on the inside or the outside?
Yes. It doesn't matter. That's what I'm just saying. If you put it up underneath, or if you put it on the outside, either one is correct. Okay, I prefer the first one though, okay? I prefer the first one. But it doesn't really matter. Alright, ready for E?
Cube root of 5x squared.
Yes, ma'am, that's it. Cube root of 5x squared. And then F,
So 5 root.
5th root. I'm going to put it in parentheses, 2x squared plus 1, raised to what power? 4. That's it. Okay, so in parts 1 and 2, there is no calculation. There are no calculations. When it says simplify, that's when you have to do some number crunching.
Darn.
The back
Oh.
doesn't look fun either.
Numbers in math.
Awful.
Simplify. Alright, let's look at example A. Part 3, example A. So remember, 25 to the half is same as square root of 25. What's square root of 25? 5. So that's it. That's A. Ready for B? Alright, B. So here, you're going to multiply exponents. So what's 6 times 3 halves? What is 6 times 3 halves? You can multiply the numerator.
9.
There you go, 9.
Mr. Schweitzer, is the library open today?
I didn't see an email saying it's closed. So this is the answer. X to the 9 is the answer. Not 9, but x to the 9.
Mr. Schweitzer,
Yeah.
can you just write it out like we did the other ones and add the exponents?
I don't understand what you're asking.
Like, can we do like square root of parentheses x is 6 and then put 3 on the outside?
You mean like square root of x to the 6 and then 3 on the outside like that?
No, the x is 6 in parentheses inside the square root.
Like that?
Yeah.
Yeah. Well, you still need this one. You have to have this one. If you're going to put the 3 on the outside, you need that.
Yeah.
Right. Well, what is square root of x to the 6? You still have to answer that question. What's square root of x to the 6? Because remember, this is not rewrite. This is simplify. So stopping here is not enough. Can I go this way? Yes, you can. But stopping here is not enough. Okay? Alright. But what is the square root of x to the 6? It's x to the 3rd. Technically, it's absolute value of x to the 3rd. But you know what? We're going to just be lazy and ignore that. And if they see me online with this, they're going to make a comment. You're not a real math teacher. Who cares? Alright. Yes, sir.
Did the answer x to the 9?
Yeah, answer is x to the 9. C. Reduce your fraction. What is 4 over 2 reduced to? 2, right? 4 over 2 is 2. What is 6 squared? 36. Yeah. Okay? Alright. Okay, now this is where the calculations get interesting. Alright, here we go. So, I'm going to do 64 to the 2/3 and x to what power? What's 3 times 2/3?
Wait, what was the question?
What is 3 times 2/3?
2.
2.
So x to the
How is it 2?
And then we figure that out.
Alright, 3 times 2/3. That's 3 over 1. So the 3's cancel and you just have 2.
Oh.
Alright, so the question is, what am I going to do with this 64 to the 2/3? It's better to do this first. So you do cube root of 64, and then you square it, right? So I did a rewrite here to help me do the calculations. But what is the cube root of 64?
8. Or not.
One more try.
That's weird.
Smaller than 8.
7, 6.
Isn't it 4?
4. So it's 4 squared. What's 4 squared?
16.
16. So that's my answer. This is my answer. 16x squared.
I would have never found that out. Would have been lost.
You're allowed to use a calculator.
Does calculator tell you that if you put it in?
Let's do it in the calculator. So 64, turn it on first. 64, let's clear that so you don't see all that other stuff. Clear. All right. 64, raise it, so there's my exponent, 2/3. Remember, fraction is same as division. Press enter, it's 16.
But I'm talking about the whole problem.
Okay, you can't put x in there. You can't put the x in the calculator. But you can do the number, right? X can't go in the calculator, but the number can go in the calculator.
So
All
all
right?
you gotta do is figure out x.
That's right.
Are there any calculators out there that you can type this whole problem in and get the answer?
Yes, but they're not allowed in most schools
Why?
because it does too much. They're allowed in college.
Because
they're not
math
the-
is higher level,
Yeah,
and
because
that becomes and doing stuff.
if you
like
can't do
becomes
that
like
stuff that the
doing
calculator can
multiplication.
do, then you won't pass that class anyway.
Wait, what?
If you can't do what the calculator can do, you're not going to pass those
So
classes. anyway.
it basically comes to us using like simple multiplication.
Yeah. All right. So this is going to be 64 to the 3/2. And what is 4 times 3/2?
6.
6. All right. And then 64 to the 3/2 is same as square root of 64 to the 3rd power. What's square root of 64?
8.
8. 8 to the 3rd is 512. How do I know that? I remember from first period today. Okay, so no magic there.
How do you get to the third?
Huh?
How do you get 64 to the third?
This thing?
Yes.
Okay, so the denominator was a 2, right? So I rewrite as a square root. And the exponent is 3, so I leave the 3 out here. So that's how I got square root of 64 to the 3rd.
How do you get x to the third?
I did 4 times 3/2.
Yeah.
I did 4 times 3/2. Right? 4 times 3 is 12. 12 over 2 is 6. All right? Moving to F. Moving to F. F. Oh my goodness. All right. So this is 343 to the 5/3 x to the, what's 9 times 5/3?
15.
15.
Can you slide over a little bit? No. Like the other one.
Other way.
You done? All right. You were just trying to delay the end of the lesson, weren't you? Okay, 343 to the 5/3 is the cube root of 343 raised to the 5th. So I don't expect you to do this in your head. Cube root of 7, sorry, cube root of 343 is 7. And then you're going to do, well, I can't do 7 to 15 in my head. In fact, I don't even remember what the answer was.
Should I do it real quick?
I'm doing it now. 16,807.
Mrs. Archer,
What did she say?
I really need to go to the bathroom. Can I please go?
That's a big number.
Is that a 0 or a 6?
He's got a
It
stick.
ain't gonna take me long.
It's a 0.
You better
You got to leave to go. All right.
Where'd you go to?
160.
That's a big number.
All right. And that's the end of the lesson. I give you some class time to work on it. Remember the last 2 problems in the homework is like the work from yesterday. The last 2 problems in the homework is like the work from yesterday.